All right, let's talk about factoring. You probably learned multiple ways of factoring in your Algebra 1 class. We are going to cover a way of factoring that works for all quadratic expressions if it is factorable. Okay, so to start, we always want to look for our greatest common factor. So if you look for example 1 or in example 1, I'm going to highlight this. Always look for your GCF. Always. Example 1 says to factor completely 4x squared minus 5x minus 6. And I look at that and I do not have a value, either a number or a variable that I can factor out of all of those terms. Okay, fine. The next step, and over on the side of your note sheet, I have these little steps over here on the side if you want to take a screenshot of that. If you don't have a hard copy of your note sheet, you can look at that. But this is what we want to do. Our first step is going to be to rewrite this quadratic expression, but we're only going to be using our a term and our c term. So we're going to say 4x squared, and instead of writing our minus 5x, we're going to break that apart into two separate values. We don't quite know what those values are going to be yet. And then we have our c term of minus 6, okay? The next step, we're going to make a chart over here. And we need to multiply together a times c. We're going to find the factors of a times c that combine to give us b. So looking at our quadratic expression, a is 4, c is negative 6. 4 times negative 6 is negative 24. And our b value is this minus 5 right here, so negative 5. So let's figure out what our factors of negative 24 are. Of course, you can go the easy route, negative 1 times 24, or positive 1 times negative 24. We can use the 4 times negative 6, or the negative 4 times positive 6. And our goal is for these factors to combine to make negative 5. So if I look so far, negative 1 plus 24 gives us 23. 1 minus 24 gives us negative 23. 4 minus 6 gives us negative 2, and negative 4 plus 6 gives us positive 2. None of those combine to make negative 5. Okay, what other factors are there? We can use positive 8 times negative 3, or, well, let's see if that adds. 8 minus 3, that's a positive 5. So we're close, we just have the wrong sign. So let's just switch the sign for our factors. We have a negative 8 times positive 3. When we combine those together, we get negative 5. This right here is what we wanted. So these are the pairs that I'm going to use, negative 8 and positive 3. So in those blanks, we're going to have a minus 8x and a plus 3x. All right, next step, we're going to group together our first two terms and our last two terms and take out a GCF from each of those. 4x squared minus 8x. They both are divisible by 4, and they're both divisible by x. So when you take 4x squared and you divide out a 4x, you're only left with x to the first power, or x. Negative 8x divided by 4x gives us minus 2. Our second set of parentheses, we have this 3x minus 6. They're both divisible by a positive 3x. You always want to bring the sign with you. Always bring the sign with you. So we can divide out a 3 from both of those terms, and we are left with 3x divided by 3 gives us x, and negative 6 divided by 3 gives us a minus 2. Now, when you look at this, hopefully you recognize that inside these parentheses are x minus 2 in both of them. And that's what you want. That's how you know you've factored appropriately, okay? So 4x and this plus 3 are both being multiplied by x minus 2. So if you put those values in their own set of parentheses like this, that means they're both being multiplied by x minus 2. And you don't have to write the x minus 2 two times. You can just leave it like this. And this is factored completely. All right, let's try it again. Factor completely 6x squared minus 15x minus 9. When I look at that, I want to check for a greatest common factor. and I look at all of my number values, my coefficient and my constant, and I see that 6 and 15 and 9 are all divisible by 3. So I am going to factor out a 3 to begin with, and then I'm going to use a bracket to leave what's left over. Since I know I'm going to be using parentheses again anyway, I don't want it to look too messy or confusing. So if we divide out or factor out a 3, that leaves us with 2x squared minus 5x minus 3, right? We divided all of these terms by 3, okay? And what's in the brackets is what's left over. So every single time we do this, we just want to bring down what's already been factored out, and we want to rewrite the trinomial that's inside the bracket, right? 2x squared, blankety blank, minus 3. We need to make sure we're separating that negative 5x. We want to break it apart into two pieces. All right, what two values do we want to use? Well, to figure that out, we're going to make our t-chart again. We need a times c that add to make b. Well, our a value is 2 and our c value is negative 3. When I multiply those together, I get negative 6. Our b value is negative 5. All right, let's list out our factors of negative 6. We'll start with the easy ones first. We have positive 6 times negative 1 or negative 6 times positive 1. Let's see what those combine to make. 6 times negative 1 gives us, 6 minus 1 combines to give us 5. And then negative 6 plus 1 gives us negative 5. Oh my goodness, I don't need to go any further. I don't need to worry about listing any other pairs because we've found what we needed. We needed our b value to combine to make negative 5. So I have a negative 6 and a positive 1. I am going to go ahead and write a minus 6x and plus 1x because both of those together give us this b term right here in the middle of negative 5x. Okay, so we're just breaking that middle term down. Now we're grouping. Okay, we're just basically slicing up this trinomial into separate pieces. We're taking one giant pizza and we're cutting it into slices. So this right here, we're going to group our first two and our last two terms together. Of course, bring down our 3. 2x squared minus 6x. Those both are divisible by a 2 and an x. And we factor those out. We are left with x minus 3. And when I look at 1x minus 3, there's not a GCF. So in that, we always have to factor out either a positive 1 or a negative 1. Okay, it acts as our placeholder. So in this instance, because I do not want my signs to change for either of those, I'm going to go ahead and factor out a plus 1. And that leaves us with x minus 3. Oops, I want black. So now I can regroup these. Oops. X minus 3 is the same as x minus 3. So 2x and our plus 1 are both being multiplied by that. So we have 2x plus 1 times x minus 3. And of course, bring down your 3. And that is completely factored. All right, let's do another example. I want to skip to make the video a little bit shorter. Let's go ahead and factor x squared minus 9. When I look at this, I notice that I'm missing a term. I don't have an x term. My b value is missing, right? So this is the same thing as saying 4x squared plus 0x minus 9. Now I know what to do with this, okay? You may have recognized this as the difference of two perfect squares. However, and there is a shortcut way to factoring that, but I'm trying to go through the way that works for all functions. And then if you want to learn a shortcut, come and see me, I'll show you, or I'll make another video. All right, here we go. There's no GCF here, so I know I'm going to rewrite this expression. We have 4x squared, blankety blank, minus 9. We're going to go ahead and make our t-chart with A times C that add to make B. My A value is 4. My C value is -9. Multiplied together, that gives us a -36. And our B value is 0. So the factors of -36 that combine to make 0. Hopefully you recognize off the top of your head that -6 times +6 gives us 0 when we add them together. So this is the pair that we need. We don't have to look any further, even though there are other pairs. And it actually doesn't matter. I forgot to tell you guys this earlier. It doesn't matter which order you put those values back into your expression. If you want to put your plus 6x first and then your minus 6x next, you can. They're reversible. It doesn't matter. In the end, you will end up with the same answer. So we're going to group our values together. 4x squared plus 6x. Both of those are divisible by a 2x. And when we factor out a 2x, we're left with 2x plus 3. And then when I look at my second binomial, -6x minus 9, we factor out a -3, and we are left with a positive 2x plus 3. So if you had factored out right here a +3 instead of a -3, your signs would be reversed. And then hopefully you would look at that and say, oh, I need to just change the sign. I need to factor out a -3 instead. So I recognize that 2x plus 3 is the same as 2x plus 3. I know I probably factored correctly. Both 2x and our -3 are being multiplied by 2x plus 3. And that is our solution. That's factored completely. Like I said, if you want to learn the pattern for the difference of squares, just come in and let me know, or ask me for a video.